welcome Josh Smith and Bridger Cohan. They both work for the Watershed Research and Training Center in Hayfork, based in Hayfork, also offices in Weaverville. Josh and Bridger will share their work on meadow inventory and assessment on the Trinity River Watershed as part of the Klamath Meadows Partnership. You might have heard about this in the news recently. Josh is the Watershed Program Director for the Stewardship Program Director for the Watershed Research and Training Center, overseeing watershed restoration, youth development, and trail stewardship. He's been involved in restoring the Trinity River watershed since 2005 and is passionate about keeping water on the landscape through meadow and floodplain restoration. He's also a really excellent youth soccer coach. I'll add that. Bridger Cohan is a meadow and riparian restoration specialist with the WRTC. He's leading meadow inventory and assessment efforts and managing restoration projects throughout Trinity County. He's got an MS in biology and a diverse background in botany, wetlands management, and watershed science. So help me out and give a good warm welcome to Josh and Bridger.
You guys hear me in the back okay? Yes. Oh, yeah. All right. Nice. Yep, so I'm Josh Smith, Watershed Stewardship Program Director at the Watershed Center. I grew up in Trinity County, moved away for about a decade, and then came back and have been working in watershed sciences since then for about 16 plus years now. This is really exciting to me. I think this is really simple, efficient, fast work that we can do a lot of good with. And so we're pretty excited about. We're just on the ground floor here getting started, but we'll go ahead and fire off. Go, Bridger.
Hey everybody, I'm Bridger Cohan, relatively new transplant to Trinity County, but a longtime Meadows enjoyer and at least since I've been here, Science on Tap enjoyer. So pretty fun to be up on stage for once. And yeah, Josh mentioned we have some super cool work happening right now, and we hope that's going to lead to some super cool meadow restoration projects down the line, and really just a better understanding of the wonderful and diverse meadows that we do have here in Trinity County.
Quick question. Anybody here on the last presentation I gave at Science on Tap that was similar-ish? One? Okay. Two? Three? All right. A few. All right. Okay, all right. Hopefully we have a lot of new stuff and it's not too much of the same stuff, so we'll see how it goes here.
All right, so just to start us off here, I want to talk a little bit about what meadows actually are. This is a slightly trickier question to answer than you might expect, because there are a lot of different types of meadows out there. There's a lot of different definitions for what a meadow actually is. The one that we like to use, at least in the Klamath Meadows Partnership for our current effort, is that a meadow is it's an open area. It doesn't have too many trees or brush or shrubs. It usually has moist soils for at least part of the year, sometimes not all the year in Trinity County especially. And then it's dominated by herbaceous plants. So that's going to be grasses, sedges, rushes, lots of wildflowers in many cases. So not trees, not shrubs. And that's a pretty unique feature of the landscape. I would say that the default habitat type here in Trinity County is forest in most places, whether that's an oak forest or pine forest or Doug fir and true firs up top. And so having an area that's open and dominated by grasses and sedges and things like that is pretty unique. And it makes it a really special habitat that can support a lot of species that we care about that forests might not be sufficient habitat for. And then also, partly, this is sort of partly how meadows form, is that they occupy pretty unique positions on the landscape. So not always, but often kind of in basins or areas where water can accumulate and drain to. Often they're associated with a pond or maybe a stream or a groundwater seep or spring. So they're pretty tied into specific locations on the landscape. That's going to kind of have some more importance down the line when I'm talking about the Lost Meadow model. So keep that in your back pocket, and I'll pass it off to you.
Yeah, and we're very focused on the wet meadows in particular with this work. Whether they're dried out now or not is to be seen on each meadow. I'm going to talk about a lot of reasons why meadows are beneficial for the environment. Number one, like Bridger already said, habitat is extremely important. For a lot of these are entirely dependent on wet meadow systems to survive. This, like sandhill crane, for example, is something I'll talk about a little bit more later. Not many of those left around here nowadays, if at all. We've got natural fire breaks. This is something that's becoming more and more important. They're good places to either be safe in during a fire or to change fire behavior if you've got a nice wet meadow system. Carbon storage. I'm actually going to let you talk about that real quick if you want.
Sure. So meadows are, you might think that forests were kind of the be-all end of carbon storage because so much was locked up in the trees, but actually meadows do a better job, wet meadows in particular, of storing carbon on the landscape because the grasses and other plants that grow in them grow really fast. They suck all that carbon down into their roots, and then it's basically just locked up. It's in wet soil. It doesn't go away very quickly as long as that meadow stays intact. And so there was a study done in the Sierras that found that there was like around 5 times as much carbon stored annually in these wet meadow systems as in the surrounding forest. So that's a ballpark. It might not be applicable to every meadow here, but for healthy ones at least, they definitely seem to store considerably more carbon. The flip side to that is that if the meadow, if you lose the meadow, if you have some of these issues that Josh is going to talk about in a little bit happen where maybe the meadow's drained or something happens where you have a bunch of trees move in, it dries out the soil, and essentially once the soil is dry, then that carbon that was locked up in there starts to get respired by other organisms, and you can lose all that really quickly. Although on the plus side, if you keep it wet, then you don't have fires going through and taking all your carbon off the top as readily. So there are a lot of benefits to meadows as a carbon sink. You just have to keep them healthy.
There's some really neat studies about beaver and their relation to fire and also carbon. And so we've been seeing that beaver habitat where it's really where it's big enough and substantial enough, even the most catastrophic wildfire will come through and those areas will still stay green and hold their habitat a lot better. Culturally and recreationally important, of course. Everybody likes a meadow. This is kind of the essence of it. This is why we spend most of our time working on this. I started looking at meadow restoration years ago because of an interest in keeping more water on the landscape for longer. As we continue to see more droughts, less water in streams, we're looking at any way possible. And this is really, we're thinking that it might have real benefits for groundwater storage. Also helps a little bit with flood attenuation. It actually acts as a sediment sink. Usually sediment comes down after a wildfire, for example, and it'll accumulate in the meadow, build up. A lot of water quality improvements, whether that's sediment or nutrients. So we're going to talk a little bit about how meadows like this, turn into meadows like this. I think, these are stylized images, but it's kind of amazing once your eyes get attuned to it. I grew up in Trinity County, but I've seen a lot of meadows that I always thought were just the way they were. And the more that I've learned about this, the more I realize that they're damaged and they need help. So there's a lot of different ways that you can cause damage to wetlands or wet meadows. They're very sensitive habitats, usually really fine soils, and they're kind of in a tenuous place on the landscape where a little bit of damage can go a long way. Here's an example. So this is a very small, kind of inconspicuous start to a head cut. So a head cut is basically a small waterfall where water's falling over the top, undercutting the bottom, and it'll move its way upstream. So it's the head of the cut that is moving upstream. So it starts off really small. You'll find these all over the places. In the biggest, most incised areas, you'll go and find these little things marching up the edges, doing more damage. So then after you get the head cut that moves up, then you get a little bit of bank erosion, some more degradation. They get worse and worse. You get continued incision, down cutting. And here's Indian Valley stream near Hayfork, where it's gotten down to bedrock for the most part, so it won't go down anymore. And then that stream power starts going and moving laterally. So once you get the incision and the head cut starting, then it concentrates all the stream flow into that little spot. It's like a fire hose instead of being able to be out across this huge space. If you had a fire hose right here across the cement, it wouldn't do a whole lot, but if it's in one particular little slot, it has a lot of power, does a lot of damage. So roads are a major problem. They're one of the major reasons why we end up with these incision points. Sometimes it's poorly drained roads. There's some nice asphalt with gravel over the top of it because there's so much erosion happening. Again, you take a culvert and you have it undersized, so it's concentrating too much flow in one particular spot, you get what's called shotgunning, where it blasts out an area, so it's concentrating that stream flow and making more erosion, or just plain old driving out through a wet meadow and they're very sensitive, and you end up with channels really fast that start concentrating that flow again. That's the same thing even with trails. This is Swift Creek. So this was the trail 2 years ago, and now there's enough water going down it that it's become a stream, and then there's a new trail formed on the sides. Here's several older trails like that in one of the meadows up there. So sometimes it's really small and there isn't a whole lot going on and it's just starting. Sometimes it's really big. So we don't have a lot of good photos. If anybody actually has any good photos of Trinity County old grazing or anything like that, we'd love to see them, love to learn more about some of the things that were happening. But this is Kings Canyon National Park, overgrazing. You can see our head cut starting to march up through the meadow. One's probably already moved through up in that amount, but now it's going to be this deep. Forest encroachment. So after a lot of what happens is after that incision happens, it dewaters the water table. So the water table was at the surface, but after it cuts down, then the water table moves down with that head cut, with that incision. So you've gotten rid of all that water that was groundwater and moved it down. So then now it's much easier for conifers to move in. So you can see here just whole bunches of, looks like maybe cedars, pines moving out into the meadow. They wouldn't be able to do that if there was water up at the surface like there was originally. There's other ways that you can get conifer encroachment too. Sometimes it's a lack of fire because we exclude fire from everywhere. We end up having this conifers move in. Could be a lack of grazing sometimes, whether that's elk or cattle or porcupine. Mining. Anybody know this photo? Ballard of Buster Scruggs, the miner in the meadow. Anyway. This is one of the dredges up in Carville. Carville used to be a pretty amazing meadow system. The old historic photos of that area look incredible. And now you drive around the corner where the fishing derby is, and that's actually where the dredge stopped, is that pond where the fishing derby is. But yeah, that dredge went through and now it's just tailings. All the topsoil, all the nice meadow material was washed away. And that's pretty pervasive. That's kind of all across Trinity County. Development. So you can have, you know, sometimes it's moving a parking lot in, sometimes it's putting a house too close. You end up building levees to protect your homes, and then that concentrates the stream flow even more. There's a lot of places in Trinity County like this. So what are we going to do about it? We are trying to work. We've been looking at this for a long time, kind of unsuccessfully for a number of years. We've had certain restoration projects like Corral Gulch and Indian Valley that Bridger is going to talk about more in a bit. But we've been really unable to get funding or to get support for this because it really wasn't known that there were meadows here that needed protection. They've been working in the Sierras for decades, but we literally weren't on the maps for the grants for a long time. So we got together with a bunch of other folks, the Klamath Meadows Partnership we formed, which is a group that's kind of led by a whole bunch of people, but it's fiscally sponsored right now by the Watershed Center. A group of NGOs, agencies, and scientists got together. They were thinking this is really important. We need to do something about it. They noticed this lack of investment and knowledge, and formed the Klamath Meadows Partnership in order to increase the pace and scale of meadow restoration. So we're really excited. This program's been hit the ground running. We've got a really great coordinator who lives on the coast, Emily Cooper, who tells she was going to try to be here, couldn't make it, and we're ramping up big time. The area of the Klamath Meadows Partnership is kind of loosely defined right now, but it's basically the Pacific Ocean, Oregon border, kind of Lassen area, and down in the Central Valley, and all the way down into the bay. So right now, most of the focus is in the Klamath, kind of mid-Klamath, Trinity River, Scott River. That's primarily where we're working right now, and hoping to expand into other areas in the near future. We'll go more over, let's see. Yeah, so I would say one more thing. So we're basically inventory. We're doing some policy work on the front end with Klamath Meadows Partnership to try to get funding for the collective group. We're trying to reach out to other groups in other regions and get this work going in other parts of the Klamath Meadows area. And then we're also doing some science, which Bridger's going to talk about.
Cool. So yeah, one of the main thrusts of the Klamath Meadows Partnership, at least this coming year, and something I'm personally really excited about, is doing that inventory effort, like Josh mentioned, and tying that into something called the Lost Meadow model. So like Josh said, we just weren't on the map in Klamath Country for a long time as far as meadows were concerned, and we do have a lot of meadows here, but they weren't well known. They aren't well known and well documented, well inventoried, and so it wasn't like we had a go-to data set where it's like, oh, these are all the meadows, these are the things that are problematic with them, you know, let's try to prioritize which ones we should put in for funding. That didn't exist, and so we're kind of working on developing that right now. And one of the first things that we're doing is to try to just get a list of the meadows that are out there and then use that to help build something called the Lost Meadow model. So this was something that was developed by the fine folks at the Pacific Southwest Research Station, part of the Forest Service down in Arcata. And it's a computer model, and this is going to sound a little bit more like a Silicon Valley investor's pitch than Science on Tap, but we're going to use big data and machine learning algorithms to try to locate meadows or places that we think could be meadows that have similar geomorphic and climatic conditions to existing meadows. So that's kind of fancy language, but really what it means is that the model, you feed it a bunch of data of places that you know are meadows. They look like meadows, they function like meadows, they're healthy. And ideally you do it in the area that you want to be looking in, because not all parts of California have the same type of geology, same type of climate. So right now, the original model was built using Sierra's Meadows data, and that's okay, but we really want to give it some Klamath Meadows data so that it knows what to look for in this area. And it's going to, you want to click through?
I was going to say one more thing real quick. Just to be clear, that the Lost Meadow part is because when there is incision and dewatering, a lot of these areas don't look at all like a meadow anymore. They look like a forest. And that is really pervasive also. We've seen that all over the place. So that's kind of where that Lost Meadow name came from.
Yeah, at some point they go from degraded to actually lost. And this model can help us find them. So the important thing about the Lost Meadow model is that it uses a whole bunch of different data. It uses slope data, it uses sort of a relative local elevation. So is it in a basin compared to surrounding features? How close is it to the nearest stream or other water feature? It has some climate data that's built in. The one thing that's not built in is any sort of vegetation data, whether that's just looking at aerial imagery, which is how I find meadows when I'm trying to go out and scout a place, is zoom around on Google Earth, look for green places, look for wet places, might be a meadow. And it does not get that data. It doesn't get any vegetation data, any aerial imagery, because we want it to look for places that kind of fit the like very basic criteria of what a meadow, or where a meadow could be, the type of landscape positions that they are often found in, even if they don't have the right vegetation that we would want to see there. So it's what's going to help us find those lost meadows they just look like forest now if you're looking at them from the top, but maybe when you're out there you're thinking, gosh, it's pretty wet here, it's pretty flat here, there's a ton of sediment that looks like it got deposited, maybe there's a couple wet meadow species that are tucked in under the trees, and so it can help you find those places a little bit more reliably. So back to the big data, in the Sierras, they had big data. You can see on the left-hand side here, this is just a map of meadows around the Yosemite region. This is just a very small portion of the data that they fed it, but each of those little purple squiggles is a meadow system. And so that's great. They have an awesome data set for their region. It helps them find lost meadow areas in the Sierras. Not as helpful here. Our data is not big data, it is small data, and it's also pretty inconsistent. There is no actual meadows data set, so we were forced to use some other data sets that we can kind of proxy for meadows, things like wetlands, frog habitat, grassy vegetation types. So it's not that we have nothing, but it's not the perfect data that we'd want to feed this model. So a little case study, this is Mumbo Basin. If anybody's ever been there, super beautiful spot, really wet, really lush. It's up at the headwaters of the East Fork Trinity River. Just south of Mount Eddy a little ways, kind of right on the dividing line between Trinity County and I believe Siskiyou County. So awesome vegetation there. You want to click forward? It also has some major problems. So you can see, this is where that photo earlier of the completely washed out road was. There's also some incision happening right there. There's some encroachment happening. And then on the right side, a little hard to see, but there's a culvert that's shotgunning water into a meadow and causing this little channel to form there and start to downcut and dry that out. So we know we want to do some work here, and we wanted to get a better handle on what was going on there. So we were looking at different data sets that we had access to and seeing how they compared to each other. First one is from the Forest Service. This is just a vegetation data set. It has all sorts of different vegetation types, but we picked out in particular, I believe like wet grassland and willow were the two that we used because those are the most similar to meadows. So it's sort of a proxy, and it shows some stuff in Mumbo Basin, not a whole lot, and we know that there's more meadow there than that just from being out there. So the next one we looked at was California Department of Fish and Wildlife has a frog habitat data set. This is focused mostly on cascade frog, species of concern that really likes meadows. And this is a cascade frog like breeding habitat inventory. So super comprehensive for our area for that specific type of habitat, but there are lots of meadows that are not necessarily good cascade frog breeding habitat, maybe a little drier, just don't have the perennial water. And so we looked at this and said, like, yeah, this is okay. It shows also some ponds that are, the center of the pond is not a meadow. It might be meadow around the periphery, but it's just standing water year round in the center. So not necessarily a meadow there either.
Justin Garwood's data set.
And then the last one that we looked at was the National Wetlands Inventory. So this is nationwide, has a bunch of different categories. Again, we kind of pruned it a little bit to get as close as we could to meadow. So we took out the forested wetlands. We took out the, I believe, like riverine wetlands and deep water, just lakes basically. And we were left with this for Mumbo Basin. So there's more area there than those other data sets. And it's in more or less the right area. But in some places it might actually be a little optimistic. And not totally comprehensive either. So we actually went out there and did our own delineations together with the RCD and with some folks in the Forest Service, and basically just walked the outline of the meadows, essentially walking the tree line in most cases. And this is what we came up with. So a little bit more detailed, and we feel like a pretty accurate and comprehensive assessment of what meadows are there right now. Now, there are some areas that are not included in this that we think probably should be meadows. And that's from being out there, you can see, again, these areas that it's really flat, it's right next to a meadow. There's some wet meadow species that are under the trees. It just has a ton of trees. So it kind of looks like a forest, but if you can imagine it without the trees, it would look like a wet meadow. And so this was a perfect opportunity to test that lost meadow model. And before we get into that, this is just all those data sets kind of layered over on each other. And you can see that there's a lot of overlap. There end up actually being about the same number of acres of inventory meadow from these other data sets as we found in our on-the-ground surveys. But they're in slightly different places. So these are useful, but not perfect. So here's that lost meadow data. I'm not sure. OK, here we go. So yeah, big areas of lost meadow here that are not captured in any of the data that we collected or the stuff that we inventoried. Almost twice as much, actually more than twice as much areas potentially lost meadow as current meadow. So this is pretty huge. If we were going to do restoration projects here, this might help us guide where we were going to be focusing our efforts, and it just gives us a sense of the scale of what we could achieve with restoration in this basin. This, I want to be very clear, is sort of a very rough draft. This is actually a model version of the model that was trained in part on Justin Garwood's that California Department of Fish and Wildlife frog data set. So one of the best things that we have as far as meadow inventory for the upper basin, but not what we want to get to eventually with this inventory effort. So we expect that this will get a little bit more refined. We'll be able to put a little bit more faith in it, but a pretty cool conceptual take about what this model can show us and how much more potential there is to increase meadow area. So if you scale that up, we didn't do it for the whole county because we didn't have the right data for that. But if you scale up to the size of the upper Trinity Basin, so everything that feeds into Lewiston Lake, there's, again, a pretty huge amount of meadow potentially available for restoration. It's not twice as much, according to this, but it's about half again as much, which is pretty huge overall. And also, this lost meadow model can help us basically try to figure out where those priority places to go and restore are, where there's a bunch of lost meadow model predictions and maybe not so much actual meadow there now.
property that you guys are going to be responsible for on that map?
It's kind of up in the top right there.
Thank you.
Mhm. So yeah, we really need a version of the Lost Meadow model that's trained on meadow data from the Klamath Mountains in order to put as much trust in this data, into these model projections as we might like in order to be able to use it effectively. So we have lots of people out on the landscape this summer, people from the Watershed Center, people from the RCD, people from the Forest Service, all going out and doing these meadow inventories. And essentially, the process is pretty simple. You look at a map or you just know where some meadow areas are, but they're not really recorded in a formal way. You go out there, you walk what you think is the boundary of the existing meadow, and then you take a bunch of notes, qualitative notes, quantitative notes, things about the hydrologic type. So is it related to a stream, or is it related to a pond? Is it a spring-based wetland where that's where it's getting its water? Or maybe it's a seasonally dry wet meadow, or seasonally dry meadow instead of a really permanently wet meadow. And then also things about key plant communities, what types of species you see there, if there's any particular rare species especially that we might be concerned about and might make us prioritize this site. And then lastly, trying to figure out if there's damage to that wet meadow system. So things like Josh was talking about, encroachment, incision, roads, all these are super common. I can't think of really any meadow that we surveyed where we didn't find at least one. But it's good to know what problems are out there, and that can help us in the future when we're trying to figure out projects. So, and the other thing was we did look just very generically for areas that we thought might be some of that lost meadow habitat. So areas that could be meadow, probably were meadow, don't really look like meadow now. The current status of our inventory effort is that just the Watershed Center and RCD helping did about 32 meadows in Trinity County so far this year. So 32 more than we had. And then the Forest Service partners did about 121, which were technically scattered throughout multiple counties, but most of them ended up being either in or really close to Trinity County, which is kind of cool. And then we also, just on a screen, looking again for those green areas, essentially found about 400 spots to go check out in the future. Some of those we might get to this summer later or this fall, others we'll have to save for next year. So a couple things we found, there were a bunch of different hydrologic types, a ton of diversity of meadows on the landscape, meadows at high elevations, meadows at low elevations, meadows associated with streams, pretty dry meadows. One thing that we did find was that not all areas that we had marked out as someplace to explore actually were in fact meadows. So this photo on the right here was one that we thought might be a meadow. In the Google Earth imagery, it looks nice and green. But that was captured in like April, and if you go out there in early July, it's really dry. It's just a serpentine barren with a lot of annual grasses on it, and so not really something that's functioning as a meadow and providing those same benefits. We did identify lots of damage to meadows, or more optimistically, restoration opportunities. And then we also found lots of areas, or at least a few areas that were really seemed to us like lost meadow, and so we'll be curious to see how those predictions stack up against what the model spits out. So I just wanted to walk through real quick a couple of the meadows that we found, because at least for me, I had an impression of meadows as being more like the Sierra. It's all high elevation. It's all these like granite bowls with a really, really wet system in it, super green, and those are great. But in Trinity County, we have more of a diversity, and there's a ton of cool spots that are pretty close into towns, not up in the Alps necessarily, although those are also beautiful. So I just want to highlight a few of these. This is near Tule Creek, near Hayfork, really cool. Just a big basin that's fed by groundwater. This was very wet when we were there. Not quite standing water, but close to it, and that was like at the end of August. This one is up in Bear Creek Basin, south of Mount Eddy along the Sisson-Callahan Trail. This is a fairly dry meadow for that area, but it's super beautiful, super productive, really, really rare habitat. This is near Hyam and the headwaters of Grassy Flat Creek. Again, pretty cool feature on the landscape. Most of the area around there is quite dry, and this is just a little bit wetter. Sustains a really interesting plant community. This, I recently learned today that in fact this is called Butcher Bob's Garden, which I never knew. Great name for this place. A really cool meadow near Hayfork. One that definitely has some issues that could use some addressing, but provides, again, super unique habitat for that area, tons of water. Here's another lush meadow near Smoky Creek, kind of near Forest Glen, and yeah, just another area that very different from the surrounding woodland. Also a place that fire has burned through fairly recently, and it seems to have been really good for the meadow. It's given it some sediment, it's given it a little more water that the trees aren't sucking up. So kind of a cool illustration of how that can be beneficial. And then lastly, this is in the Connor Creek headwaters near Junction City. Hawker Flat Meadow, one that some people may be familiar with, another really cool spot. This is not a huge meadow area. This is probably like half of it in this one photo, but again, very unique spot on the landscape. Seems to get a lot of wildlife use just right here. So there's tons of cool places. These are just a few of them. So just to kind of sum that all up, as far as the Klamath Meadow Partnership and our current and future efforts, it's kind of a virtuous cycle that we're hoping to get in. So you have this lost meadow model. It can help you find places to go out and take a look at. You go out and take a look at them. You get good inventory data, and then you feed that back into the model, make it more accurate, get more predictions. You go out and check those, and hopefully you're getting to a cycle where you can build up a version of the model where it's not only going to show you all the meadows that do exist currently, but it's also going to show you a lot of places where it says there's a meadow there, but you go out and you look and it's just trees. But maybe you can start to have more confidence that those are places that could potentially be restored, even if they're pretty forested now. And so we're gonna talk about one of those places out at Corral Gulch in a little bit, where it's mostly forest now, but we're pretty sure, even without the lost meadow model, just based on historical accounts and some Forest Service reports, that it was in fact meadow back in the day. And there are things that you can do to repair and restore those lost meadows, even though it's a little bit more difficult than one that just has a little head cut or something.
Just if anybody's wondering, we just didn't run the model down here. It's not that there aren't meadows past Hayfork, Trinity River.
Yeah, there's actually a lot down there. So yeah, just a few kind of takeaways from the inventory effort and our plans for the Klamath Meadows Partnership. We're very invested in the lost meadow model and in finding these lost meadows, maybe repairing them. However, it's definitely a lot easier to do restoration work when the meadow is not lost yet. And so this inventory can really stand on its own as something that we just go out and try to figure out where the meadows are, what are the issues with them, and then how can we prioritize these for restoration, maybe get some funding. And so if we can identify when there is encroachment happening, little conifers starting to march into the meadow, or incision happening, and get on that right away, that's going to be something that's pretty important. And to help us with that, one of the big focuses of the Klamath Meadows Partnership is to figure out some streamlined permitting pathways. So for at least small scale projects, we don't necessarily have to wait super long in order to be able to carry those out once we find these places that need help. So here's just, I guess, two photos. One, this is sort of like what you can achieve with some of these meadow restoration techniques is really impressive. I mean,
This is before the project. There's that stump, and then after the project.
Yeah.
And the permitting part, we're talking about going into streams, dumping trees in, moving sediment around in streams, things that we normally can't do. And so the permitting is difficult and takes time. But these are some folks. This is from Paul Powers, a guy with the U.S. Forest Service in Oregon, who's been doing this for decades. And they see pretty amazing results on really huge scales. Okay, so we're going to jump to a particular project. This is a project that I've been trying to work on for probably going on 10 years easily. Here's Hayfork. So you go out towards Indian Valley, out Tule Creek Road, way up over the top of the hill and up into the upper flat. There's kind of a flat basin back there behind Hayfork. The Corral Gulch. This started as Indian Valley project itself, and then that is kind of so big and there's so many problems that we've decided to start on Corral Gulch, so show some success there, which is a tributary to Indian Valley Creek, and see if we can't get to Indian Valley later on. So some of these photos are from either Indian Valley or Corral. They're kind of intermixed. This is the upper part of Indian Valley Creek that's still relatively intact. It has some culverts kind of holding the groundwater table up a little bit, so it's still a little bit intact. This is Carla DeJulio out in lower Indian Valley Creek. So that's that's the depth of incision. That's not even the worst of it, but it's a pretty bad site. And how could that happen? This is pretty substantial. Not only is it that deep, but it's between 150 sometimes even 200 plus feet wide, this incised channel at this point. So yeah, I mean, it starts off that, like we said, we think that, well, actually, I'm going to jump ahead real quick. I think it's easier. So we found this historical report from the U.S. Forest Service. I think, you know, they realized how bad of a problem it was. This is in the 1940s. They said Indian Valley is the #1 control problem on the forest. So they knew it was a problem. They knew incision was happening. They knew that the meadows were falling apart. There's a lot of really neat tidbits in this report. It talks about overgrazing, it talks about the new roads, the logging. It's kind of a poster child of all the things that we talked about. The grazing, I should say, is really substantial. It wasn't numbers like we have out there now. It was thousands, well,
at least hundreds yeah.
of sheep and cows all over the place. It also talks about, you know, really lush grasses, year-round springs running through the whole place. A completely different environment than what's up there now. There's hardly any water there in the summertime now. So we have a lot of historical evidence. They actually went and they put in a bunch of gabion baskets to try to stop the erosion in the 60s and 70s to try to save the Indian Valley Guard Station and to slow the incision. And it kind of worked a little bit, but that stuff's kind of falling apart. So again, you know, we have incised channels that have kind of cut up through these nice, lush, wet meadow systems, dewatered it. That the conifers have encroached in. They're so big now. These are, you know, 30-inch plus, sometimes even bigger, you know, ponderosa pines. So it looks like an old forest at this point, productive place for growing trees. But again, by late summer, there's no flows. So this is, again, we don't have photos of Indian Valley Creek, so we've got these historic photos from that kind of show the idea from the Sierras. So overgrazing, incision starts, the gullies get to be pretty substantial. This might have been in the 1940s in Indian Valley where they said, you know, we need to do something about this. I'll also say that I have some pretty cool interactions with Ray Patton, who is a Norelmuck, Wintu, and a Forest Service employee. And he tells me that Indian Valley, the original name for Indian Valley is the sound that a sandhill crane makes. So, you know, we believe that there used to be sandhill cranes up there, and now it's, like I said, completely dry. So again, you know, these are other pictures of Indian Valley Creek with some of the really active erosion that's happening, continuing to happen. This is a little bit of a segue. This is called the stream evolution model. There's a group of scientists, one from England and the other from the Bay Area, who decided to work together. Brian Kleur is a pilot as well as a geomorphologist, so he's flying around the U.S. looking down on river systems all over the place, and he kept noticing things that were patterns, and he started talking to other professionals about it. And he met this guy, Colin Thorne, who's from England and works in University of Nottingham. And Colin had been looking at basically how we've on purpose removed wet meadow systems in all these places where we live. So most of the biggest civilizations in Europe, most of the biggest cities are built on these types of wet meadow floodplain areas, and we've you know, channelized them and removed and put up levees to protect our houses. And then there's a lot of really cool examples of this in some of Colin's papers. But essentially, we've on purpose, you know, made habitat for ourselves and removed the floodplain, removed all of the benefits that we get. Like, for example, when you get floods, you get sediment that goes out across the floodplain and becomes good fertilizer, good soil. Anyway, so these guys worked together and they kind of developed this model of what they think a river system would be in a very flat environment. We're not talking about the headwaters up in the Alps. We're talking about the flat zones. So they're saying that this is kind of an evolution of a stream in degradation, is what it's showing. So it starts off, maybe it's a forest with multiple channels. That's showing that a flat area wouldn't just have a single channel in it. Quite often it would have multiple channels. So whether it's a forest or it's a open meadow, flat channels. You start to get your incision, you start to have your trees, your lateral widening, kind of continued degradation. And then at a certain point, and you'll see, we're pretty confident actually that Hayfork Creek and Hayfork is like this, where it's so bad, it's actually created its own new floodplain, its own new environment down in the incised channel. But essentially, you kind of can't ever get back to here naturally. It'll kind of stay down here, unless there's a really catastrophic flood event or something like that. So we talk about that. I'm saying this because this comes up a lot in the discussions about this type of restoration. We call it stage 0 valley reset. If we're gonna try to reset a really degraded system, we've been calling it stage 0 valley reset. So how do we take it from this incised channel and try to make it back into a wet meadow? So again, going from the really degraded stage, try to get back up to the stage 0. So one example of that, this is a Yurok tribe project over in Indian Creek. This was the first of its type in the state, if I'm not mistaken. Really heavy-handed, right? So this doesn't look very pretty when it's happening. This is like, I try to tell people this type of restoration is like surgery. You don't actually want to be there and see it happening. You just want to see the results afterwards. So yeah, we've got heavy equipment that is basically scalping off the top of the high areas and dumping all that sediment into the channel, into that incised channel. So this is, again, why the permitting is really hard on this type of thing, is we're doing the opposite of what we've said we should do for years and years. But you're basically, and it doesn't look, again, like when they finished, it kind of looked like a parking lot, to be honest, but over time it fills in. This is that same area during the flood event. I think it was this last winter.
It was, last winter. Or the winter before.
And if you go out there, you'll see the groundwater table's up. This isn't perfect. I'm not saying that this is the be-all, end-all, but I think there's a lot of really good benefits. The groundwater table is substantially higher than it used to be. The vegetation is going crazy, and that'll continue to help build it up and create structure and slow down that water. What else about this?
Good fish habitat.
Yeah, good fish habitat. And I think there are plans to go back and work on it some more and kind of fix it up, make it right. We also, we've really been believing that I think, some of the small, simple work can also go with this kind of big, heavy-handed work. Some places need the big, heavy-handed work with the heavy equipment because Indian Valley, for example, using small scale stuff it's going to take 1,000 years of small lifts to build it back up to where it needs to be.
You were talking about Indian Valley, but Indian Creek is southeast of Douglas City. Is that correct?
Correct.
Okay, good. It looks good.
Nice. You like it? I think it looks amazing compared to what it used to be. This is an incredibly mined out place. So this is a side note, but when they were doing the analysis trying to figure out what the grade line should be of the valley, there were literally no surfaces that they could go back and look at that say this was an original floodplain surface. It was all gone. So very difficult to try to figure out what the original setting was like there.
And just to be clear, Indian Valley, Indian Creek are separate.
Thank you. Indian Valley, Hayfork, Watershed Center is leading that project. Indian Creek is a Yurok focus project in the Douglas City area. Elk love this, by the way. So this is what I was saying with small scale. So, some places require huge equipment to get something back. Some places are very simple. This is just really recent. We went to a meadow restoration training in the Scott Valley. This is Rock Fence Creek. And we had done this work. This was a bunch of volunteers and some brand new people who'd never done this work before. And you could just see the groundwater table, the extra green in the area behind the dam. It's a very small little handmade dam. This is incredibly satisfying work. I really want to get kids out as much as possible to start doing this work. It's fun. Most everybody that does it, they say, the first thing they come back and say is that, oh man, I haven't done something like this since I was a kid. I felt like a kid out there. So it's really cheap. here in this case, you're laying some logs, lengthwise along the creek. You take the conifers that have encroached into the meadow that shouldn't be there, cut them down, hand build structures in the stream. Sometimes it's along the stream, sometimes it's crossways. A lot of this kind of happens on its own to a certain extent. When the trees die, they fall in, start creating little mini dams. You'll see lots of sediment accumulation behind it, and you'll get water popping back. We were actually just out in Corral Gulch with one of the meadow restoration specialists last week, looking in every single place where there had been a natural debris jam of logs during a flood event, and there was sediment backed up behind it. There'd be a pool of water below it, and there's no other water around in the rest of the watershed right now. So we just accelerate this kind of work. So it'd be basically hand crews, small stuff.
Yeah. So that kind of little mini dam building work that Josh was mentioning, we usually refer to as low-tech process-based restoration. And then the PBR, yes. So we have better options than that here, but at the Trinity Brewery. So the Corral Gulch restoration project that we have planned does incorporate some of that low-tech process-based restoration, and it also incorporates some of that heavy equipment work like the work we're doing on Indian Creek. And we think that kind of that hybrid approach can really give us the best bang for our buck and help us to quickly recover areas where that's needed and recover some other areas that are just less disturbed without causing more disturbance, than it's worth. So we're going to do a bunch of things with this project. The main thing is to restore a level stage 0 surface. So in those diagrams that Josh was showing, the stage 0 surface is essentially the floodplain. So you can have multiple channels. They're all kind of in the same elevation. They're not cut down. That's our stage 0 surface that we're talking about. And then that's going to be in the lower about 2/3 of the project area. And we're going to, at the top of that stage 0 reach is a road crossing to N18. We're going to build that up just a little bit and armor it so that it is the same elevation as our newly risen stage 0 floodplain. And then we're also going to use that as a little bit of a top grade control. So flows that are coming down from above it in the watershed shouldn't start to channelize our new surface there. We're going to put a whole bunch of large wood throughout the project area because we have a ton of trees to work with. And large wood is actually really important for these stage 0 systems. Josh mentioned that the natural process to reset a valley into stage 0 is usually a huge catastrophic flood. And that's going to leave things just littered around the landscape. And if you don't have that large wood out there, what can happen is that as soon as you do have flow, there's no real vegetation yet right off the bat. So you're doing this project in the fall, late summer when it's nice and dry, and then you get a bunch of storms. If you don't have any trees, flow can start to accumulate. It can start to form a single channel, and then that channel can just cut right back down through your new sediment. You really don't want that. So all these trees over the landscape are basically going to be like a pinball machine where that flow is going to hit one, it's going to bounce around to the other direction, it might split in half, it might form a pool, and then kind of just go into the groundwater. And so this large wood's pretty critical to the success of the project in that it breaks up that flow and spreads out the water across the meadow. And then, the slide's a long one. We're going to use that low-tech process-based restoration, anywhere that needs it really, but focusing primarily on the upper tributaries, where the incision's not as bad. We think we can hit those with the little check dams, wooden check dams, and quickly and effectively repair those. We're going to put a whole bunch of seed and little plugs of native plants back on the landscape. There's some wet meadow vegetation there, but it's in like tiny little pockets, and we want to see it all over the place. We think we're going to create a bunch of great habitat for it. And then we're also going to put some fencing in around there to protect that vegetation while it's coming back. This might be a place that can sustain grazing in the future, but right off the bat, we want to give those plants a chance to establish themselves and not get mowed down immediately. And then finally, we're going to do a bunch of monitoring just to make sure that we're having the results that we want for this project. So monitoring the groundwater, monitoring the water in the creek, vegetation, things like that. Hopefully get some really cool photos out of it as well. All right, so we saved some of the more technical slides for the very end when you guys are a little deep into your beers. In retrospect, not sure about that choice, but here we are. So this slide is showing a whole bunch of different things, but really at the end of the day, that green line is our stage 0 surface. So that's what we're trying to get to. So
This is the long section profile. So this is a survey view of the stream channel is in blue, and then where we want to be is in green.
Yeah, so that blue line is like the bottom of the current stream channel, and the green line is going to be that new stage 0 surface. But the thing about stage 0 is that it should also be your stream channel depth at that point, right? Because your water is spread out all over the place. There is no real channel when you're in stage 0. And so we're getting a pretty substantial lift here. It's several feet in most cases above the current depth of the stream channel. And so all of that fill is basically where we can store groundwater, where it's currently just draining out. The other thing to notice about this is that towards the bottom right there, you can see there's a little a bedrock grade control feature, and that's really critical for the success of this project because it's going to act as a plug, basically. This is a natural feature. We're not putting this in, but it's going to act as a plug that prevents our sediment from draining out of the project area. We're going to be taking a whole bunch of sediment off the landscape, moving it into the channel. We want to make sure it stays there, and so we've kind of designed this project so that it's all going to tie into that bedrock outcrop at the bottom, and that's not going anywhere. So that should keep it there for the foreseeable future.
One of the amazing things about this type of project is that, we're dumping sediment in the stream, which, seems like you'll have more sediment downstream. But if it works right, if we do it right, it actually accumulates sediment throughout the project area. It'll absorb the sediment, keep it there, instead of letting it downstream. So it'll be a lot less sediment downstream.
So that stage 0 surface, the green line, essentially, if you can imagine you're going downstream and it's a pretty straight line. Everywhere along that line has a particular elevation associated with it, and we use that to generate a relative elevation map. So relative to our stage 0 surface, where is the current surface? This is just kind of a zoomed in view. This isn't the whole project area, but you can see essentially the blues and the pinks and purples are areas that are really below that stage 0 surface. So they're pretty incised, in some cases really, really incised, like up to 5.5 feet in the pink spots. And then areas that are the kind of warmer colors, greens, yellows, oranges, are going to be raised surfaces. And so we use this type of map to basically figure out where do we need to put fill, how much fill do we need to put there in order to bring it up, and then where can we find that fill material. We didn't want to take it off of surfaces that were already good floodplain, already at that stage 0 level. And so this is sort of the basis of our project design. And essentially what we came up with is this is a more basic design than we'll actually be using out there, but all those blue areas are places where we're going to take fill and put them into the channel. You can see they're basically following the creek right now. And then there's all the orange areas are places where it's kind of raised above the floodplain and we feel like we can take fill. We're not going to take fill from all of those orange places. We wanted to have some extra available in case there were certain spots we couldn't work, if it was rocky. But it's going to give us plenty of extra to play with just in case, and it'll be more than enough to basically fill that whole creek channel up to that stage 0 surface. So this is LiDAR. It's just a really, really high resolution digital elevation map of Corral Gulch right now in our project area. Hopefully everybody can see that there's a pretty obvious channel that runs through the middle of that project area. It's, it winds around a little bit, but it's very noticeable, both in this map and also when you're out there. And then in the next slide, this is how we hope that it looks afterwards. This is less clear here than I was anticipating, but essentially that whole brown area is flat. If you look at it, it just looks like a smooth surface, and that's basically what we're aiming for afterwards. There's going to be a lot of debris out there, those logs that I was mentioning earlier, but the actual ground surface should be really smooth for this whole thing, and that's going to spread out the water. It's going to slow the water. As Josh mentioned, it shouldn't be cutting into this. It's going to be so slowed and spread out that even if there's a lot of flood water with a lot of sediment in it, it's going to actually have that sediment settle out into this area and start to build up that floodplain again, which will be pretty cool to see and hopefully provide some great habitat. This is going to be, if everything goes to plan, about 24 acres worth of restored wet meadow habitat, which is a lot more than exists out there right now, probably in the entire Indian Valley area. So not the end of the road for restoration in the Indian Valley area, but we do hope that this is a really good proof of concept and something that may not look great the first year or two, but give it a couple of years, go out there. It could be a great spot for a picnic, great spot to hunt. It's going to look really cool, and I think a pretty unique feature of the landscape in this coming years.
One of my favorite things about this type of work, this process-based restoration work, is we're kind of giving the stream back its original channel, and it gets to do what it wants. We're not going to try to keep it in one place. It's going to move around back and forth, be stochastic like it would want to be in the first place. So this is what I love about these.
How much does this project cost?
About $1.5 million, a little less. It's a decent chunk. Mm-hmm.
Any other questions?
Is the road the only infrastructure that you're worried about if the channel starts to meander?
Yeah, good question. The question was, is the road the only thing that we're worried about, the only infrastructure there? Yes, that's the only thing that's of any concern out there is that road. And this type of work can only be done in certain places because of that. We have a project where we're designing on Salt Creek in Hayfork, and it's got a lot more infrastructure problems, and that definitely changes how we think about it, how we design it, all that kind of stuff. Sweet. Thanks, everybody.
All right.
All right. Big round of applause for Josh and Bridger.